Hello everyone, welcome back. So in this video, we are going to understand a very important question from the Leetcode is next special palindrome we have to find. Okay, what the question is saying that let's understand. Very first, we have given a number and we have given. Okay, so a number is a special if it's a palindrome, right? Means we can read from where forward and backward, right? Like we have 22, we can say 2 2 2 2. Can we say that? Means both direction we can say. Okay, very first we have given what? A number we have given. So a number is a special if it's a palindrome, right? Means we can read from forward and backward both direction. Okay, for example, we can take 1 2 2 1. Also we can take, or 2 2 we can say. So if we'll start from here, we can say 1 2 2 1, right? If we'll start from here, 1 2 2 1, right? Both are, we can say. But in this case, if we'll take 1 2 3 4, right? This is not same as we can see. So this is not palindrome, this is your palindrome. I hope you understand the very first concept. Okay, so a number is a special if it is a palindrome. That you understand, means we can read from forward and backward in the same way. Okay, now another point it is saying, right, every digit, right, every digit k appears exactly how many times? K times, right? So let's suppose we have, if the digit we will take is 2, right? So it must appear exactly how many times? It should appear exactly how many times? 2 times in number. If the digit is not 3, is 4. If the digit is 4, it means what? It must appears exactly how many times? 4 times in number. Can we say that? So digit is present or not present, right? It all depends on what? The given number, right? And from the given number, we can check the given digit k is appearing k times or not, right? So digit not present can appear 0 times, if we'll say. Okay, I hope you understand. Let's understand now. If we have given a number is 22, is this palindrome? Yes, it is palindrome. Now found the count of 2. How many counts we have? Is 2 we have 1 1 2. So match requirement found, right? We can say okay. So the digit k numbers appear in the number appears exactly k times. How many times? 2 times. Means say it's matching. The requirement is matching. Matches requirement, we can say. And so it's a special palindrome. Understand? So you will say, what is the confusion? Now your confusion will get out. Okay, understand, we have given a number. Okay, so can we take 3 1 and 3? 3 1 3 will be a palindrome or not? We can say we can read from here to here, we can read from here to here. Yes, this is palindrome, no problem. Then I will say okay, count 3 in this number. How many is there? 1 and 2. It's 2. So is it matching exactly 3 times? No, right? It is not matching. It should be 3, not the 2. If it is 3, it's good, but it is not 2. It's not 3. So it is not matching. So the match must be exactly 3 times. Okay, so this is not special. Understand? Now you can understand the given examples. In example 1, we have given n equal to 2. If the input, that is number, we have given n equal to 2, so we want the next special palindrome greater than what? 2. What we want? We want the next special palindrome which is greater than 2. Let's check. Is 3 palindrome? No. Is 4? No. Like that, we'll keep going that. When we reach 22, we'll say, yes, this is a palindrome. And 2 appears how many times? Twice. Means matches. Means the output is 22. And that is why it is coming 22. I hope you understand, right? So what approach we are going to do, right? Many approaches are there. Okay. One of the approach, if you want in the DFS approach, right? So what you can do, you can pre-compute all these special palindrome up to length 16. Okay. And then you can pick the next one after n. For example, n we have, so you can pick the next, what is the next special palindrome, you can pick directly, right? So the DFS parameter will take, let's suppose, the length of the palindrome that we are going to build, right? Then we can take mid will be the middle digit of the odd length, right? And we'll take d, that is the depth of recurrence, because we have to compute it, right? We have to position that we are filling from the left side, right? That we will do. And then the now means the number being performed, n, right? The number we can say. And other will take the count, how many times each digit is currently used for this one. Okay, so let's understand how your DFS will work. Okay, so let's suppose your length is how many? 4. Okay, means in this case the position should be what? You can say 0, 1, 2 and 3, correct? So we will fill what? Symmetric pair. How? Very first pair will be, we will fill how? 0, 3. Then we'll fill 1, 2. Like that we will fill. Then we'll check if we will choose digit 2, right? From both ends, right? From both ends, here and here, both side. Let's suppose call 2 and 2, and whatever you are taking here. What are the counts are there? Count is 2. What is the next pair? Maybe 4 digits is there. So we'll take 4, 4. How many counts is there? Count of 4 is also 2. So we'll say count is also 2, right? Means very first count at 2 will say is 2. Count at 4 is, we'll say 4. Not 4, 2, right? So we'll keep checking this one, right? So what are the constants we will check? We'll check digit 2 appears how many times? 2 times. Digit 4 appears how many times? 2 times. Okay, this is palindrome. Add it to the answer. We'll add it to the answer. Okay. So when the length is what? Even number, n equal to 4. Now think if n equal to 5, then what we need to do? If length we will take is 5, then what will happen? You will start from 0, 1, 2, 3 and one more you have to take 4, right? Then we'll set the middle part. We need, right, the middle part, because we'll take 5, this and this. What is the middle? This is the middle, right? So middle part we have to set. Means we have to fill how? Let's suppose we'll take 2, middle part will be left. Let's suppose this is 3 and this is 2. So this and this we have to fill out, right? So let's suppose if this is coming is 4 and 4. Similarly, we can count and we can check if this is palindrome, we'll add it to the answer. So how this search works, right? That is the next thing we have to understand. So we'll, once you find all the palindromes are generated and stored in the answer, right? Once those are generated and you have added into the answer, right? What you need to do, we have to find the next palindrome is just binary of n. If we'll do the binary search of n, you can find it, right? And then you will return the next number in the list. Let's understand how to do that. So let me clean it. Okay, very first let's take, we have to initialize a function. So we'll say init. Okay, so this function will do very first what? It will do pre-compute. Let's say p, and it is a powers of of 10, we can say, right? Then we'll generate palindrome via DFS, right? So DFS will be a function, right? Very first, what we need to do, so DFS will place says the pair in I and I order. If it is symmetry, means this is symmetrically, right? So only even, if it is only even digits that we have seen, right? Except middle is odd length, right? Then we'll track what? Track the count that we have taken, track the count, okay, for all the digit that we have used, okay? And then we'll check when it is full, check constant and save in answer. Once these are done, this part is done, what we do the next, check all a special palindrome in answer. If it is done, then we'll do what? Binary search for n, right? And this will be your, it will return your next integer. Okay, let's understand through the code. So now let's understand the code. Okay, so very first you should build the skeleton like this, right? So this is your function that we have given n, right? And we have to check the special palindrome, right? And for that, very first you initialize the things that is required. Is what are the things we required? So these are the class level variables that you should define. Okay, you'll understand what are these things. Okay, then once you initialize this, then you should find the index of the as I told you, that binary search you will apply on the answer once you build the answer, right? And then then you will get the index, right? And on index you will check if index is greater than or equal to 0, you will return answer dot get index plus 1, you will return, or otherwise you will do what? Index minus 1 you will do, and you will return it. I hope you understand. Then internally what we are doing when we are calculating the defining the init, right? So if you observe here, so this is the initialization method. Okay, so first understand the overview. Okay, what is the requirement is here, right? So this program will pre-compute all the what you call a special palindrome, right? That number is where up to 16, right? You can say up to 16 digit, right? That we will take, right? So very first what we should do, we should take those numbers, right? And we'll pre-compute all those values and we'll store into the answer. Okay, then the special palindrome is a palindrome where digit k appears exactly how many times? K times, right? So after pre-compute, right, this function means this will pre-compute after pre-computation, right? Or this function will take the argument n, right? And it will find the smallest special palindrome which is strictly greater than what? N, using the binary search. So we'll do the binary search, right? You will get the index, right, using binary search, and the next strictly greater than, right? So for the strictly greater than means find the smallest palindrome, strictly greater than it was saying, right? So we'll do index plus 1, right? And that we are doing through the binary search. So this is the thing that we need to do. So I was saying this thing, right? This part. So what we need to do, we have to define some class level variables, right? So what they hold actually, very first we'll take initiate. What it will do, I will explain later. Just think that very first we'll take this power of 10 and we'll keep storing at here. How? When you write 10 to the power what? Let's suppose I 10 to the power this, right? We are doing, right? So this will be stored at where? Some e at I. not like that. You can say equal to. So this will be some value. Let's suppose random value, I'm taking any value. Okay, so that value will get stored at here. Okay, means power of 10, I is what? Power of 10, and that power of 10 we have to store where? At here. Okay, and this is answer is nothing but the pre-computed special palindrome that we have discussed earlier, right? And what is this count? So will this count will we use while building the palindrome, right? Remember when we are doing digit wise, right? So per digit wise we will find the count and we'll store here. That we will do here, right? Very first I told you what. So P will help us to place the digit at a correct decimal position, right? And count at D means the digit, right? It will count how many times digit D has been placed on one side of the palindrome, right? That is you can say number of symmetric placement that we are doing, right? That time. So the total occurrence contributed to the pair, how we are going to find it? So we can say occurrence, total occurrence contributed to a pair, we can do what? Count at what? At D, right? And that you need to multiply. Understand? If you know the count, right, from one side, if you want the total occurrence contributed by the pair, right, you just need to do what? Multiply by the count, right? If there is a centered digit, let's suppose mid, right, that adds one more extra to that digit, will do +1, right? Otherwise for all the values we'll just do multiply. I hope till now you have understood everything. So what is this initiated? So it initiated means we have initialized or not. Means if everything goes well, right, first we'll check if initiated is true, will return, will not do anything, will not do pre-compute. So whenever you calling this, right, we'll check this, it is initiated or not, because this is a class level. So we want first to initialize the pre-compute everything, right? We'll check if initiated, will return true. Okay, will not do anything. Otherwise very first we'll mark the initiated as true. If you go here, if you see here, so we'll check if initiated is true, will return anything. We don't need to reinitialize this one. Okay, so to avoid the reinitialization, we'll build this one. Okay, so what are the things we are doing here in initialization, right? As you can see here, we are writing here what? Very first we done the guard, right? We have initiated. Once we compute, we don't need to recompute. Then we fill P with the power of 10 up to what? Up to 16. So you need to just do up to 16, power of 16 up to power of 10. P with the power of 10 up to 16 we will do. And we need to add one more. Add one as a special single digit if appears once, right? Then we need to generate all the even length palindrome, right? You just do what? DFS, you will pass the length mid 0, D0, and now is 0, right? So all you pass 0 0 0. Okay, then we will check for we want to generate all the odd length palindrome. For each odd length middle digit, let's suppose some value we have. For example, if we'll take mid, we'll take 1 3 5 7 9, right? Then we will call the value, right? So this we can say for each digit, middle digit, let's suppose we'll take mid at this, right? We'll call DFS with now, right? It will initialize to the middle digit at the center, right? How we are going to do? We will take the mid at 1 to 10 and we'll do mid plus 2 each time we will do, and you will find the we'll calculate this value, right? We'll do DFS, right? Mid will be there, mid into, as I told you, P length by 2 you will do, you will just multiply it. Means we want to build the what you call we want to initialize the middle digit at the center position, and for that You just need to do what? Mid into this value, means length by 2. Okay. And once this is done, just do the collection dot sort to make the binary search safe, right? That is done. Okay. So this will be our initialization part, right? The very first you have initialized all these requirements, right? Now it's time to do the binary search. Once you do the binary search, right, you will check these values, it will operate the value, right? And DFS you have already applied, right? The DFS function you have already created as we have discussed earlier, right? Till here. Okay, let me zoom out here. Okay, so you are passing the digit and this is your current value now, right? You just keep checking if the d is equal to length by 2, you will apply this one. Otherwise power left power right you will do, right? You will check from 2 to 10 you will go each time, and as I told you, you will do now left and right you will do apply DFS. Count will be minus minus. If mid is greater than 0, count with this one. You will do the count plus plus, I will increase. So each time count will get increases, right? Once you call the DFS, you decrease the count. Okay. 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 So once you got this everything done, you will just check the index, right? If index is fine, you will return it. So let's understand a little bit this one also. Okay. So we have this length we have, then we have mid we have. So length, you know, this length is nothing but what? Total length of the target palindrome that we are sending, right? And this mid is, if it is greater than 0, we'll choose center digit for odd length, otherwise 0 will take, right? And this d is nothing but the current depth. We will fill the symmetric pair at index d to length minus 1 minus d, correct? And then it will be our what do you call now current value. As you can see, when we are talking about the left, we are taking what? Length minus 1 minus d. When we are talking about the only the starting one, right? Like, because we want to fill the symmetry pair from where at index d, you can get the index d here, right? When you want, right? So index d will be at here, starting right side, and the left side will be the left bound. So this is your left bound and right bound. Okay. Yeah, I think that's all, right? So this part is nothing but your base case. Okay, you just checking the length equal to digit equal to length by 2, right? So you need to verify every digit the users it meets the requirement or not, right? So you will go at 2 to, let's suppose 2 to 9 you will go, right? I will go to 2 to 9, right? Then you will keep checking the value, right? If the count not is 0 and some value is coming I by 2, will return, will not do anything, you will not go further. If mid is greater than 0 and you will check this count, you will return it, right? Similarly, you will keep adding the now here, right? Means what we are trying to do, when all the pairs places d, right? Half of the length will verify the digit. If we was used count at I not equal to 0, it must be equal to I by 2. So that is why we are doing I by 2, because the pair contributes to 2 count occurrence which must be equal to I when I is even. If there is a center digit mid, so we'll calculate the mid here. Okay. And this is nothing but your recursive function. So in this recursive step, what you need to do? You just start with the left and right as I told you, right? Put even digit in the symmetry position, right? And place the middle digit only if odd length of the palindrome with a specified mid is there, right? So all will do like this, means all the even will put here, right? All the even digits when the symmetry position is happening, and when we'll place if the middle digit is only the odd length, right? Then we will put like this one. Okay. And then we will, so we have built the answer. Once you build the answer, you will just check if n exists answer at index greater than or equal to 0 will return the next element. What? Index plus 1 you will do strictly greater. If not found, you will return what? The insertion position in the minus 1. It will give you index minus 1. It will give you the negative, right? So the smallest answer is greater than n, we return the answer, the insertion position. I hope you understand. Still, if I doubt, let me know in the comment section. Thank you guys. Thank you for watching this video.